So in question 3 here, we need to find this x value, okay? Note first, we have alternate angles at here and down here. Okay, so these base angles, or these angles down here, this one up here, and this one will be equal. So let's call that angle x, which means that we can call this angle up here x as well. Okay, we'll talk about that in a minute. But then notice we have a triangle here. So we actually have 3 angles within the triangle that will add up to 180. So that's the first thing we can do. We can add these 3 angles. So we'll have 27 plus 100 plus x, which is not that x, by the way. I guess I should have called that another letter, shouldn't I? So let's call that A plus A. So we'll change it to A equals 180. Okay, so add those angles up, you'll get A being 53 degrees. So this is angles in a triangle, and they add up to 180. So we find that this angle down here is 53, and this angle therefore is 53. And then we'll notice, once we clear that out, that we have our angle at the center being x, and this is our angle at the circumference, which will be 53. So then we use that rule, angle at the center equals 2 times angle at circumference. So angle at the center is x, 2 times angle at the circumference is 53. Therefore, x will be 106 degrees. So that's this angle here. Okay, so in question 4, we have 5 questions to find, or 5 answers to get. And the first one is ABE. So angle ABE is here. So this angle here. And we use our rule that the angle at the center is 2 times the angle at the circumference. So we could write that here. So angle at the center equals 2 times angle at circumference. So angle at the center is 87. 2 times angle at circumference. So let's just call that A. So that would be 2A. So A then is going to be 43.5. Okay, so this angle here is 43.5. And then we notice that we have angles in the same segment, up, down, up, down. So this angle here is the same as this one. So this is angle EDA. This is angle B here. So this angle and this angle are equal. So we could say angle B is also 43.5. And that's angles in the same segment. We could also have used this angle at center rule and angle at circumference as well to do that one. So this is A and B, they're both 43.5. So to get angle FBC, so FBC is this angle here, this will be angle C. So to get this angle, we just subtract from 180, don't we? So 180 minus 43.5 will be equal to C. And in that case, you'll get 136.5. So that would be angles on a straight line for this one here. So this is 136.5 degrees. And because this is 43, and this is 43, this is also 136.5, this angle here. So we'll add them into here in a minute. So that's 136.5. That is angle D, FDC. So FDC is this angle here. So we've got this angle, and we know that this angle is 25. And you should note here you have a quadrilateral. Okay, so that means that we can find the last answer, DFB, which is this angle in here. Okay, so we need to find this angle here. So let's do that here. So let's call that E. So E plus 136.5, but then we multiply that by 2 because we have 2 of them here. And then we add 25. And that should equal 360. So this is angles in quadrilateral. That's the name of the rule there. And they add up to 360. And so you should get 62 degrees for your final answer. So this should be 62 degrees. A and B were 43.5. These two were 136.5. So hopefully you got those 5 answers there. So let's highlight them. So that's your final solution.